Alright, welcome back to another episode of Project Euler. This is Professor Killionaire, and let's jump right into it. So problem 5, 2520 is the smallest number that can be divided by each number of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all the numbers from 1 to 20? So, I like this problem because you don't actually need to use any code to solve it. And I think that's what I'm actually going to do, since my main goal is to teach you how to solve these problems and not how to really program in Java, since I'm assuming most of you know how to do that. I think I'm just going to show you how to do this longhand instead of actually writing the code to do it, because, I don't know, it'll be fun. Alright, so basically the first thing that we need to understand in order to solve this problem is understanding what a least common multiple is, because in the end the answer to the problem is the least common multiple of all the values from 1 to 20. For some of you guys, I just told you the answer, and I'm sorry about that, but if you think about it, it makes perfect sense, and I suggest you think about it before just solving it. So basically, if you don't know what a least common multiple is, I'll try and explain it really quick. I mean, I'm pretty sure a lot of you guys know what it is, but I mean, just for the sake of formality. So a multiple is a number in which a specific number can be multiplied into an integer that it will debate what a number can be multiplied into. So an example is the multiples of 3 are 6, 9, 12, 15, 18, and so on. And the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, and so on. And so in order to find a common multiple, you have to look at all the multiples between the numbers and find which one is common. And so a common multiple between 3 and 5 is 15. And also another one would be 30 or something like that. And so this is a common multiple. And in order to find a least common multiple, what a least common multiple is the multiple with the least value in a set of numbers. And so in this case it would just be 15. But in this case, in like 4, and the least common multiple between 4 and 5 is it'd be 20, because 20 is a common multiple and it's also the least common multiple. Okay, so now let's. So in the problem it states that 2,520 is the smallest number that can be divided by each of the numbers from 1 to 10. That's another way to phrase that is, what is the least common multiple of all the values between 1 and 10? Because what that will output is the multiple of all those numbers which has the least value, and that would give you this number if Project Euler printed out the right number, assumingly they did. Obviously they did. So the best way to find the least common multiple between more than two numbers is prime factorization and finding distinct primes. And what I mean by that is writing out all the prime numbers that will multiply into a specific number, and then finding the distinct primes. And so I'll write that out for 1 to 10. I just my computer's smart, so it knows how to do that, I guess. Anyway, so I'll kind of explain this real briefly. So prime factorization of 1 is 1, prime factorization of 2 is 2, prime factorization of 3 is 3, prime factorization of 4 is 2 squared, and so on. I'm sure this makes sense to all of you, because you guys are all extremely bright. So the reason this gives you the least common multiple is it takes all the okay, so you have to, in order to find the least common multiple, you need to multiply all the distinct primes. And what a distinct prime is a prime number that occurs only once, I guess you could say. It's a number that is raised to a degree, and that's the only instance in which it exists in all the prime numbers. And so what I mean by that is, it's difficult to explain since I didn't really prepare too much before this, but if you look up what a distinct prime is, I think that would be of a lot more value than what I'm telling you right now. But anyway, so how I like to think of it is, when you're doing this, you find all the values. Oh, you find the primes, and then the prime with the highest degree for a specific integer a. So let's say a raised to n. If I want to find the distinct prime number for a in this situation, I'd find a with the highest value of n. And so let's just apply that. So ignoring 1, since 1, anything multiplied by 1 is just 1, so it's not important. If we go to 2, if we say 2 is a, what value of n, what's the highest value, what's the highest degree in which 2 is raised to? And we'll look through all these. Whoa. And we'll see that 2 squared is higher than that, and we'll see 2 cubed. And so 2 cubed does not exist anywhere else, or there's no numbers that are higher than 2 cubed. And so that is the distinct prime for 2. And so we'll plop that in right there. And as I said, we have to multiply all the distinct primes. We'll move on to 3. Is there any higher number? What's the highest degree of 3? And we'll see that it's 3 squared. Then we'll move on to 5. The highest degree of 5 is 5. Not percent sign, it's 5. 7. Highest degree of 7 is 7. And then that's actually it. Typically I'd use calculator for this, but since I already have it in text form, I'll just go to Google and plop it in their little search engine, assuming my I don't know. Oh, that's when I did it and it didn't work, but hopefully this time it'll work. Okay, so it gives us this value, which is, thank God, it's the value that Project Euler printed out. So that's cool. So now all we have to do in order to find the least common multiple of 1 to 20 is just do this with the values from the remaining values. Hopefully I can just skip ahead to where this is all filled out. Okay, so basically that is the these are the numbers from 11 to 20. This is a prime factorization of the numbers from 11 to 20, and I really hope you can kind of fill in the blanks on how I got to these values. Here's our original thing, and so basically all we have to do is, I mean, if we want, we can put parentheses around it, like it's not gonna make a difference. Just to denote that these were the values from 1 to 10, and these will be 11 to 20. So what the problem is asking is, what's the least common multiple of all the numbers between 1 to 20? And so we can continue this. Well, actually, we'll have to restart it, since the highest degree of 2 is now going to be equal to 16. This is 2 to the 4th. So that's a new highest degree for 2. And the new highest degree for 3 is still 3 squared, since 3 cubed doesn't exist anywhere, because that would be 27, and that's not a value. Same for 5 and 7. And so we're going to move on to the next prime number, which is 11, which is just prime factorization for 11, times 11. The next prime number is 13 times 13. It's just a number, it's not squared or anything. So it's the least degree. The next prime number is 17 times 17. The next prime number is 19. And so what this should give us is our value for the problem. And I think I'll just let you guys do it, because I don't know, I just feel like it's kind of a better thing to do than just pop the answer on the screen, so you guys can skip to the end of the video and watch it. Anyway, thanks for watching this one. It was a little bit longer than I hoped, but I hope I explained everything. And honestly, like, if you didn't understand anything about the least common multiple thing, I highly suggest you go look that up, because I'm probably not the best person to explain that to you at this moment, because I didn't. Anyway, it doesn't matter. Have a good day.